Okay, can you hear me? मेरी आवाज आ रही है?
Yes, sir.
ओके ओके, तो फिर कैमरा ऑन करो जल्दी से अटेंडेंस के लिए। तो अब हमारा थोड़ा सा है ये, सो लेट मी स्टार्ट शेयरिंग द स्क्रीन। इसको करेंगे हम खत्म। तो सो फार यूजिंग जो हमारे प्रीवियस थ्योरम्स हैं, हम कुछ इस तरह का एसोसिएशन डिफाइन कर चुके हैं, h which is a continuous function, जो हम अभी तक साबित कर चुके हैं, h is continuous from y to k, right? यानी h belongs to cy, ये हम प्रूव कर चुके हैं। So we also have been able to define a map from tau y to x, and we show that this tau is an isomorphism, and they are related to t via this formula. वो ये है कि t star of del y is equal to h of y into del sub tau y. मतलब this is our connect करता है इन सब चीजों को relation. So I have been able to show that tau is a continuous map. I have also shown that tau is 1 1. I want to show that this tau is 1 2, and you have to remember that t star m b m y was equal to, because t b and x, then it means that it's extreme points, because it's a linear bijection. So b map होंगे एक दूसरे पे, so this would be extreme points of b, यहाँ y है, so x. अब चूंकि onto map है between these extreme sets, it's an onto map, so something here, there should be something here. तो मैंने क्या कहा कि अगर let, now to show that, चलो करते हैं, to show that tau is onto, so let x belong to x, then since tau t star is surjective, we can conclude that there exists mu belonging here, belonging to the extreme points of b and y, such that t star of mu is equal to del x, because for every x belonging to x, del x does belong to b mx, right? So that's the idea. Okay. Moreover, for some beta belonging to k with modulus of beta equal to 1, right? And y belonging to y, I must have mu must be equal to beta del y. Why? Because of course this mu जो है ये यहाँ belong करता है और इसके extreme points इस type के होते हैं, right? Measure space. Now we have, now del x then would be equal to t star of b del y, but you have to remember now थोड़ा सा कि these are the corresponding functionals also. ये कहने का मतलब है this would be beta t star of del y, because t star is linear, which would be equal to, by definition, t star of del y जो है is defined as, कहाँ गया वो जो ना मैंने सारा दिखाया था वो मैप, हाँ, so it is h of y into delta sub tau y. That's our definition of t star del y. Now that would imply that you can easily check that इसका मतलब है beta is equal to h y bar. Yeah, because these are, I can think of them as functionals. This is a functional, this is a functional. Apply it to one, yeah, apply it to x if you are looking for a measure. तो अगर x space को apply करेंगे as a measure तो क्या मिलेगा? Because these are measures, है ना? So del x at x होगा, फिर अगर ऐसा है, it should be, ये तो मतलब as functions they are same, so you should get del tau y of जिस पर भी एक्ट करेगा ऑफ कोर्स x. सो क्योंकि ये 1 है, ये भी 1 है, so it is beta into h of y. So beta would be equal to 1 by h of y, which is equal to h of y bar divided by mod of h y square, because they are numbers. ये 1 है, so it is equal to h y bar. ठीक है ना? So beta would be equal to h y bar, and of course अगर beta h y bar के बराबर है तो ये तो फिर 1 हो जाएगा. तो you should have del x is equal to delta y, which would imply that x is equal to tau of y. है ना? Because this is on to ये जो f था हमारा वो मैप था ना हमारा, नहीं मतलब that was a well defined map. कौन सा? वो जो f कैपिटल मैप था जो x को भेजता है del x पे, this was a 1-1 map. So yeah, it was a well defined map. So if del x, कैसे मैं करूँ, f of x is equal to del x जो है वो 1-to-1 मैप है, उससे तुम्हें मिल जाएगा कि अगर del x y के बराबर है then x is equal to del y, क्योंकि it's like x is equal to y, it means f of x अगर f of y के बराबर हो तो चूंकि ये well defined मैप है then x is equal to y, कुछ ऐसा ही. Anyway, तो उससे हमें मिला कि for every x here I have been able to find y belongs to y such that x is equal to tau of y. Therefore tau is onto. Hence, this tau, a map from y to x, is a continuous bijection. और जो कि हम इससे पहले भी बहुत बार idea use कर चुके हैं. Since y is compact, actually both are compact Hausdorff, but since y compact है and x Hausdorff है, actually दोनों compact Hausdorff है, but this would be enough to show that, to imply that tau is a homeomorphism. तो हमारा काम तो ऑलमोस्ट हो गया, हमें h भी मिल गया, continuous tau भी मिल गया, तो homeomorphism. Now let f belong to cx and y belong to y. अब हमें वो फॉर्मूला एस्टैब्लिश करना. So tf at y is equal to, is the same thing as del y at t of f. Well, that is the definition of how this del works, right? ये functional जो है इसकी यही property है, but that would be by definition of the conjugate t star of del y of f. But t star of del y of, by our definition, जिस तरह से हमने इसको देखा है, del y of f का जो होगा, it would be hy into del tau y applied to f, because this thing is equal to this thing, so applying both to f, so that is nothing but h of y into f of tau y. That's the definition of this function. Okay, and that settles which proves star, जो हमने original equation जो हमें prove करनी थी, and we are done. अब इसमें हमने क्या किया, हमने वो functional और measure को interchangeably, मतलब एक तो है ना वो functional, दूसरा है measure, एक तो है ये functional, दूसरा है ये measure. X does not, x belongs to a, it's equal to 0 if x does not belong to a. तो हमने एक दो जगह इसको मुझे लगता है interchangeably use किया, but we can do that because there is a one-to-one correspondence between this functional and this measure via that relation that joins cx star to mx. तो उसमें उनका आपस में one-to-one correspondence है, that preserves everything, so that can be done. तो otherwise हमने Banach-Stone theorem prove किया, and that finishes our syllabus. And let me stop share. Camera सभी on करो. 19 आए आज. Camera on. सब सो गए. Camera on. सभी. तो हमारा second CI कब है अब? सीआर कहाँ है?
सर
अभी फिक्स नहीं हुआ, लेकिन सीआर को शायद उसका देना है ना टेंटेटिव, कुछ आया था ना वो व्हाट्सएप ग्रुप में।
यस सर।
हाँ, तो सेकंड सीआर अब चूंकि हमारी क्लास नहीं होगी ना, या अगर तुम चाहो तो आई कैन बीच में हम एक क्लास दे सकते हैं ना, जब अगर तुम्हें किसी जगह समझ ना आए तो यू कैन जस्ट गो देयर अगेन इन केस यू वांट टू स्टडी इट वेल। तुम सभी कैमरा ऑन कर सकते हो अभी। हाँ,